Hello everyone and welcome back to Arctic Retro. I'm back again with this Sinclair Spectrum Plus, which I couldn't repair in a previous video. So this is part 2 of that, and since that video I have gotten hold on a couple of things that's gonna help me try to fix it. Alright, let's do a little recap of what I did in the last video. And I suggest you take a look at that video before you watch this one. As I said in part 1, the ZX Spectrum Plus is just a little bit more fancier version than the ZX Spectrum, the original. It has a different case and a little bit different keyboard, but otherwise it's exactly the same. And the motherboard and everything inside is exactly the same. This is an issue 2 board from 1982. One other difference is that this machine has a reset button here on the side. Alright, so in the first video I did a couple of things. I actually thought it was some RAM issue, but it wasn't. However, I pulled out and tested all the RAM chips. They were fine. Did a lot of other tests, and I figured out eventually that there were one transistor that were blown, and I swapped that with one from a good machine. And also the voltage regulator, first of all, was not working, so that was swapped. And also had this diagnostics ROM, but I got a couple of feedbacks on the part 1 video that it isn't sufficient to just insert this kind of 27C diagnostics ROM. You actually need to do some modifications to use those kind of chips directly. So still it kind of worked, but yeah, the machine does still not work. So I actually suspect that it was the ULA chip, and I got a new ULA chip I'm gonna test out in this video. Before I continue, I just want to say thank you to my sponsor PCBWay. They do a great job at producing prototype PCBs. I have used them many times, so I really appreciate the cooperation. If you want to have produced your own PCBs, then just visit PCBWay.com and you can get an instant quote right now with 10 PCBs for as low as $5 US. Besides PCB manufacturing, they also do CNC machining, sheet metal fabrication and 3D printing. So that's all your needs for your hobby projects. Also visit their shared project site, where you can find a lot of ready-made great designs, which you can order PCBs directly from this site. So go ahead and visit PCBWay.com right now. Let's take a look at the new chip. This is a V Retro Design Limited made chip, and it's called VLA82. So kind of strange name. Yeah, but it is a modern replacement for the original ULA chip, and it looks like that. Yeah, let's take a closer look. It has, as you can see, just a FPGA chip on this side from Xilinx. On the other side there isn't much there. There's some small surface mount components on that. Yeah, pretty advanced, but it wasn't very expensive at all. Alright, gonna test that pretty soon. And I also got one more thing, and this is the ZX diag cartridge from Byte Delight. And Byte Delight, they provides lots of solutions for the Sinclair machines, both finished solutions and as kits. And I have built other kits from them before, and yeah, the documentation and the quality is always very nice. I built a complete ZX Spectrum once before. You can take a look at that video if you want to. You'll find it if you search. So we need to build this one up because it's a kit and there's just a bunch of parts and a PCB, and obviously this will involve a lot of soldering. And there's the chips, and it comes with a lot of sockets, and all the smaller parts. So this is the first part of this video. It's about building this cartridge. And I always like to build something, and this is going to be fun, so please watch. By the way, this kit cost me a total of 60 British pounds, and yeah, I guess that's around close to 80, 90 euros or something like that. So I want to build this first so that I can run the diagnostics with the old ULA chip first, and yeah, if we can't figure out anything from that, then I'll test the new ULA chip and see if that helps. Hopefully it will. Alright, so let's turn on the soldering station here and get ready for some soldering action. Now, before you start soldering, it's always a recommendation to read through the documentation, and this has a build guide, because there's always some things that you need to consider and some tricks and details here that you might otherwise miss. So I'm gonna do that before I start soldering, obviously. And there's a link there to a YouTube video. I haven't looked at that. Everything is, as always, neatly packaged and labeled, and yeah, it's sorted into resistors, and yeah, all those through-hole components are actually already bent, so no need to use time on that. That's real good. Yeah, so I think this should be kind of easy, and the PCB looks very nice. There's one already soldered on chip and a couple of small capacitors and resistors already. All the rest are regular old through holes. Before soldering, I always use a little alcohol to clean off the PCB first. There might be some leftover fat or dirt or dust, so good idea to get rid of that before you solder. Otherwise, new PCBs like these, usually you don't need any flux when you solder, except the flux that's in the solder you're using. So, alright, I won't show you the whole job here because yeah, it's probably gonna take me an hour or something like that. I'm just gonna start, and if something special comes up, then I'll check in. Yeah, there's even the schematics here. That's nice. Before I start, I'm just gonna go through a little bit about the features. It has some hardware features. That's a bunch of LEDs, in fact 20 LEDs that shows you data lines and power lines and everything. And then there's some built-in software in ROM that has some tools, and the default diagnostic tool tests the internal ROM, lower and upper RAM, and the RAM paging and interrupts. And this can also be used with not just the regular ZX Spectrum or Spectrum Plus, but also other models like the 128. So here are the steps, and it always recommends you to start with the smallest components first, like diodes and resistors, and then move over to the sockets, and then LEDs, capacitors, transistors, and finally the pin headers and jumpers. And there's also some switches, and it also tells you how to solder on the edge connector, which can be a little bit tricky because all the pins needs to be bent first, because they are gonna grab onto the edge of the PCB before soldering. Yes, and all the small plastic bags are numbered in the order they suggest you solder them in. So I'll start with number 1, which is a Zener diode. and it's D1, so we just need to find D1 on the PCB. And I can see now there's even a few more SMD components already populated here, so be a little bit careful that you don't knock them off or push them off while soldering other components. And as usual, different components have different characteristics. Some are polar and some are non-polar, and that means that some needs to go in one direction, like diodes, and some components like resistors, they don't care about the direction. And however, this one, you can see D1, it has a little marking on the end of the symbol, and that corresponds with the black ring on the actual component. So that's kind of easy. Okay, so I'm going to put in this and a few other components. If they don't keep themselves in position before you solder, you can just bend the leg a little bit on the back side. Sometimes I prefer to do that, sometimes not. And then I'm at the same time, just to speed it up a little bit, I'm gonna solder in all those 330 ohm resistors. I guess they are for current limiting the LEDs, so 10 of those. Even though the direction of the resistor doesn't matter, I just try to place them in the same direction, all resistors, so it looks a little bit neater, I would say. So R5 is there. That was the first components in, and another trick you can use if you don't want to bend all the legs, just use a little tape over them if you have rows like this. That will keep them nice and flat. Yeah, and one other reason to start with the lowest or smallest component first is obviously if you turn the board around like this now, then they will be held in place by the board itself. Okay, let's do a little soldering. Obviously important to have a clean solder iron tip and a good solder iron and the correct temperature. I have it set to 367 degrees Celsius, and it should flow very nicely and make a shiny solder point. And with the solder iron you touch both the pin and the hole at the same time, and then just push a little bit solder in between. Not too much solder or it will flow through to the other side. You actually want it to flow through, but not too much. And you see after a while the tip is starting to get black and dirty, then just clean it up, either with a little bit of brass wool like this, or if you have a sponge with the water, some prefer that. Oops, a little hard to reach between the forest of resistor legs. Okay, that was all. I think they all look good. Then just cut them off. Yeah, and the result, as you can see, a little bit of solder came out on the other side, so that's good. Back side looks alright. There's some leftover flux, so I'm gonna clean up the board when I'm finished. Okay, I'm just going to continue now with the rest of the small components, and then I'll be back. Okay, that was the smaller parts, and the board looks good. Everything went well, I must say. I had a little trouble with this transistor. The three legs were very close and I managed to bridge them together, but I fixed that with some solder braid. And now in with the sockets and finally the edge connector. Yeah, sockets are straightforward. Just make sure the notch on the socket is in the same direction as the notch on the silk screen on the design. The board, I mean. Yeah, this sits firmly there, so no need to secure it or anything. Usually I just solder 2 of the corner pins first, and then I just push it up from the other side to make it really flush. It might look like I'm using a lot of solder because I'm feeding a lot of length, but this is a very thin solder wire. I think it's 0.04 or 0.5 millimeters. That was one chip, just 5 more to go. That was all those sockets, and finally I'm gonna solder in this one. And yeah, I forgot to have a couple of jumpers and 2 switches. I'll of course solder those in as well. However, this edge connector, it's too wide for us to solder it in on the board, so just need to slightly bend the pins a little bit inwards on both sides so that it will fit. Yeah, something like that. Maybe a little bit more on that side, so it sits at an angle on the board. Straight. It should be straight, obviously. No, I think it grips. Yeah, and there's an open space there. Obviously that goes where that gap in the pads are. Okay, now I solder 2 pins and then I straighten it. Looks kind of straight already. Just adjusting a little bit and push it in so it sits flush with the PCB. Then just solder the rest. Start on the other side. Alright, we're done and it's looking good. Just need to put in the chips and then we can test it. However, gonna do a little bit cleaning first with some IPA. The build is finished and it looks very nice. I inserted the chips and yeah, it's cleaned and all is good. It came with this 3D printed stand to hold it level at your table, I guess. Okay, let's check it out. To test if the card is working, I'm first gonna test it on this machine. This is my home-built modern variant of the ZX Spectrum, and yeah, I built this in another video some months back. You should check it out. It works great. So this is a Harlequin board. I also got this from Byte Delight, and it uses only brand new components. All right, let's test it. So this cartridge, or shall we call it diagnostics card, it uses yeah, It has kind of two modes. Either you can just watch the LEDs to get the status of what's working or not on the machine, or you can use the built-in software where you hold a key while turning the machine on. So first we're gonna start without doing that. Yeah, and that didn't do much. Okay, it wasn't properly in. Let's try again. Okay. Yeah. So, seems like it works, and it runs a test on the on the screen. So that about holding a key, I don't think that was... yeah, this is the ZX Spectrum diagnostics. That's something else, I think. On the board itself, we see the activity on the data bus here, and we can see all the 8 lines are busy. The blue LEDs are for other control signals. M1, non-maskable interrupt, ROM, chip select, IQR2, MREC, RD, write, reset. Yes, and as you can see, this machine fully works. There's 2 buttons. As you saw, I soldered them in, and the right switch is to reset the machine, and the left switch starts a keyboard test program. You need to press that switch while it's running the test, but here is that keyboard tester, so that's kind of nice. So this dead flesh keyboard seems to be working fine. On the green LEDs we can see the voltages that comes out from the machine, and there's plus 5 volts and there's plus 9 volts, but no minus 5 and no plus 12 volts, so this is correct on this machine. However, on the original ZX Spectrum you would have a plus 12 volts. Here's a ULA ASIC test. So it says interrupt test, movement should be smooth. On this particular machine the ULA has been replaced with a lot of other logic chips instead, so that's why this machine has a lot more ICs than the original ZX Spectrum. And here we can check output tone to mic port and output tone to ear port. Test border generation, test screen switching, test ULA port addressing. So the way this works, when you start, you see the letters on the screen, you're gonna hold that. For example, if you want to do a memory test, you hold M. So there's the memory test. This is another test. No AI, hold Q to quit. Don't know what this is. Finally, this page shows you some details about the ZX diagnostics, the build number, and yeah, how much ROM space you have free. Host Alforge PC. Alright, that's enough with the testing of a known good machine. Let's test my faulty one, the one we want to repair. So this is the symptom of this sick ZX Spectrum Plus, and doesn't look very nice. Okay, so let's test the diag cartridge and see if it gives us anything. Hopefully it will manage to display something on the screen. Yes, it does. I think the green color is just an adjustment issue for the video signal, but yeah, it actually functions. Okay, so there we have the first issue, unknown or corrupt ROM. But the RAM is seemingly fine. Gonna try and adjust a little bit on those potentiometers, see if we can fix the color. Yeah, that's more like it. Well, it shouldn't be green, should be white. Okay, now it's a little bit better, at least it's a little bit white, not greenish, and we can see the correct colors. This machine unfortunately only has RF signal out. The other one had composite video, much better. So here we can see there's some issue with the ROM, and yeah, RAM and interrupts are passed, and paging in Spectrum ROM is wait, because the ROM is obviously faulty then. So very nice with this diag card. Then here we can see the status on all the different control lines and the data bus, and everything seems alright. And on this machine we got +5, -5, +9 and 12 volts. So with that information, I actually need to swap the ROM, and I have a spare here. I don't know if it's working or not, but I'm gonna try that one for sure. Yeah, it's the same with that unknown or corrupt ROM 2364 chip. So if it actually is both ROMs are broken, then alright, then it's time to take out the Retro Chip Tester Pro and test those ROMs. So I tested the first ROM, and it actually gives a consistent checksum. So it ends with 19B. Let's test again. (19B). However, the other ROM actually gets a different checksum each time, so that indicates it's faulty. So I'm not really sure if the ROM is the fault, but at least it's not functioning. So I'm gonna check the signals on the whole chip to see if everything looks alright with the oscilloscope, and then I'll be back. So I checked with the oscilloscope, and I can't find anything wrong with the ROM electrically. There seems to be normal signals on every pin, both the data lines and address lines, and no issue there. However, I realized I did test the ROM chips the wrong way. I thought this was 2364 chip, but it's actually a 23128, and there's a specific test for that. So there's 23128, and you can even select the ZX Spectrum here. Let's see now. Okay, it says EEPROM is empty. Okay, so maybe the chip is faulty after all. So I don't have another spare for the ROM. However, there is of course a ROM in this machine. I'll pull it out and check with that. This is a burnt 27 EEPROM, and yeah, as I mentioned, supposedly you can't use 27 ROMs, EEPROMs in this machine. You have to do some modifications for that to happen. There's some links there that needs to be removed, and you need some a couple of diodes and stuff. However, since the diagnostics ROM did work, I actually is wondering, does this board support EEPROMs, 27C type of EEPROMs? So just gonna test this to see. Maybe there's been done some modifications to this. I mean, the wire links here seems like a little bit home soldered, in fact. Yeah, definitely there's a big blob there, and maybe there's been done some mods to this already. I just took out the heatsink to take a look under it. Let's see now what happens. Alright, it actually passed detected the Spectrum 1648K ROM. Look at that. So that burnt 27C256 ROM actually worked. At least it passes the test here. So now it tests paging in Spectrum ROM. That was not possible before when the ROM was bad. Yeah, Okay, look at that. It put into the machine the basic. The machine works. Yay! So much work for that, but in the end it was the ROM that's bad or not compatible with this machine. I don't know what happened here, why it can use a 27 EEPROM. But still, maybe the actual original ROM is bad because it couldn't be detected in the Retro Chip Tester Pro. Very nice. Now all I have to do is to copy this ROM onto another EEPROM, and then this machine works. But yeah, there's still a little bit work to be done on this. Need to clean it up a little bit, and the keyboard isn't very good. It works, but the enter key is stuck when you press it. I just use my EEPROM burner here and yeah, read in the contents. I said the 27C256. This is a 27C128 chip. So I just select that in the software and read. Yeah. There we see the content of the ROM, and yeah, you can see the basic commands here, stuff like that. Got another one here. It's a different brand, but I think it's the same. I think it's blank, but I don't know for sure. Let's just try and program it then. No, it failed. Let me try this one. No, it failed too. To erase these UV erasable EEPROMs, you obviously need some UV light. And I have a special eraser here, so just place the chips in that and I erase them for 35 minutes. I don't think you need that long, but that's the maximum. And now this shines UV light onto the chips and they're being erased. All right, let's see now. I have an erased chip here. Yes, programming flash. After you have read a chip and you want to write it to another type of chip, you need to select the correct chip type, select IC here. Okay, it does not work. Strange. Well, that was another kind of chip. It's just a 27, not a 27C. I don't know if that's relevant for this machine. However, the other chip worked. Okay, so I found another chip. This is ST27C128, and this one programmed a lot faster than the other one. So yeah, maybe it's a speed issue. In fact, I think this is the same chip as the one that we had working. What the heck? So this is the other diagnostics test that's on internal ROM, and as you can see, that's also on a 27C128, and it's working just fine. And this is with the EEPROM from the red machine. Okay, I'm gonna call this a fix. I'm gonna use this EEPROM here, and I'm gonna try the one I burnt in the red machine. Maybe that machine is a little bit more forgiving. Let me check the red machine. Does it work with the new EEPROM? Yeah, it works just fine. Nice. Okay, then we're good. We have working Sinclair ZX Spectrum homemade red machine, this one, with a newly burnt ROM. And we have a working ZX Spectrum Plus with a burnt ROM. Okay, we're almost at the end. The only thing I want to take a look at is this keyboard. If I press enter, the key sticks down, won't come up. If we push it to the side, it comes up. By the way, I got the new caps shift key from Noel at Noel's Retro Lab. He was kind enough to send me one after I tried to print one that didn't fit, but this is the correct original key. So okay, let me try and just take off this keycap here. All the rest of the keys looks to be in good nick here, so there's not much space between the keys, so I just need to pry it from the side. Hopefully I won't break it, but yeah, I'm gonna be careful. Yes, so doesn't appear to be anything dirty or anything wrong there, so not really sure why it sticks. And yeah, it pushes, and the spring seems to be all right. I don't want to take off the whole membrane and the whole plate here, because it could be difficult to get it back into place and get it working again. So maybe just repositioning it and get a little bit of lubrication here on the side will help. Just a little bit of silicone spray. Yeah, that was it. Doesn't stick anymore, but yeah, it seems a little bit uneven. If you push here, it goes a little bit askew down, but just need to remember to push it right there. But it doesn't stick anymore, at least. No less than 8 screws on the back here. Yeah, the machine is finished, cleaned up and all looking good. Now, the final thing obviously I need to do is to check out a game on this one. For that I'm using the ZX Frankenstein. It's a device that lets you load programs from a SD micro card and also has a Kempson joystick interface. Yes, that worked. Now I just need to select which kind of game I want to load and then just use the regular cassette load command here. And then press play. Obviously I forgot to insert the cable because you of course need to load through the cassette port. It's not that advanced. What the heck is this? I just turned on the machine again and now it doesn't boot. So I inserted the diagnostics again. Let's see what happened now. New fault. Well, it comes up, it's just black and white. What happened here? All right. Okay, we have another fault now suddenly. RAM fail. Chip 6 and 7. Okay. Why? This machine doesn't seem to want to work. Maybe something happened when I plugged in that ZX Frankenstein, and yeah, I don't know. Maybe that just killed the RAM. I mean, it started with it in, but the next time after I plugged in the audio cable, it wouldn't start again. So, okay then, we just have to check the RAM chips then. All right, what a bummer. So I checked a little bit, I tested all the RAM chips and they are all fine, so it must be something else. But no, the machine seems to have totally broken down. It won't even show me anything on the diagnostics test even. I tried a different ULA chip, but it was the same. So I think I have to stop now because this video got long enough. I was really happy that I fixed the machine and you saw it working. What I think has happened is when I connected this one and the extra power, somehow something has happened, and yeah, maybe some over voltage or anything like that. So I actually need to do more work on this machine, but not in this video, obviously. Still, I hope you enjoyed this video. I built the diagnostics cartridge, which is very handy when you need to figure out what's wrong with these ZX spectrums. And yeah, also fixed the machine once, but then I managed to damage it again. So that's how it is. This old stuff, you never know when things are gonna break. So I just want to say thanks a lot for watching, and see you later, and a special thanks to my patrons. Bye bye.